So in ideal flow, we have two basic situation. One is doublet plus linear, and the other one is doublet plus vortex plus linear. So in doublet plus linear, we have the idea of flow around cylinder, because when doublet merge with linear, so the flow will flow like this one, and it is reflecting the flow around a cylinder. So and then you may calculate the value of doublet here, and then you substitute into the equation, and finally you will get the stream function of flow around cylinder as shown in this slide. So and then you may calculate the velocity components. So the velocity component is here for UR, and because the flow is around the cylinder, so the value of UR is equal to 0. Then, so if you calculate the U theta, so you will find that the value of U theta is shown like this one. So and then if you calculate, you will find that R is constant, which is equal to A, and U theta is 2U sine theta. So, and if you calculate this one, you will find that the stagnation point, so the stagnation point means the velocity is equal to 0. So it is occur at theta equal to 0 and 180 degree. So and then we calculate the pressure on cylinder surface. So from Bernoulli equation, we have this equation, and then we substitute with the value of this one. V1 is equal to U. U here is the linear velocity, and V2 is equal to 2U sine theta. So this velocity is actually came from this calculation. So point 1 and point 2 is actually, you could assume that it is point 1 at this point, which is linear. So that's why we take V1 is equal to U2, and here is point number 2. So we take the value of U theta. So and then we could write this term. So and then we could calculate it, or we could define the pressure coefficient Cp here as shown in this slide. So and then if we rearrange our previous equation, we could get that P2 can be written like this one, and then we could calculate the drag force. So the drag force here is actually the resistance occur, mean the drag force is actually the force that react with your motion in X direction. So drag force adalah daya yang bertindak selari dengan arah pergerakan. So sekiranya angin bertindak seperti itu, okay, secara logiknya angin boleh menolak bola ini bergerak ke sebelah kiri, dan untuk mengekalkan bola ini ataupun untuk mengekalkan silinder ini berada pada tempatnya, kita perlu mengenakan daya yang sama pada arah yang berlawanan. So itu adalah takrifan secara general apa yang dimaksudkan drag force. So awak pun boleh imagine bahawa sekiranya awak ada kereta kotak seperti ini, okay, dengan sebuah kereta sport, okay, so awak akan mengatakan bahawa drag force untuk kereta berbentuk kotak adalah lebih tinggi berbanding dengan kereta yang streamline. Okay, jadi saya harap awak boleh imagine berkenaan dengan drag force. Okay, the equation of drag force is shown like this one, and then if we substitute the value of F here with P and A like this one, so we could, if you solve this by the limit of 0 and 2 pi, so we could get that the value is equal to 0. So and then this is the calculation of lift force. Okay, I already explained about the lift force. We have sometime in textbook they will give you lift and down force. Okay, in lift force, so we have the equation like this one. So we substitute the value of F by multiplying P2 sine theta and A. So again, if we solve the integration here by the limit of 0 and 2 pi here, so we get it is equal to 0. So I hope you could remember all these equations. So and then we would like to explain, I would like to explain to you about the flow around rotating cylinder. So it can be reflecting by merging or by combine the idea of doublet, vortex and linear. So what is flow around cylinder? So flow around cylinder is something like we have a cylinder, flow around rotating cylinder. So we have a cylinder here. So we imagine that our cylinder is rotate at certain speed. So please remember that we have a linear speed and we have a rotational speed. Okay, rotational. So linear speed, the unit is meter per second, and rotational speed, the unit is maybe radian per second or RPM. So now means if you are solving flow around rotating cylinder, please make sure that you capable to convert from linear to rotational or from rotational to linear velocity, because it is very important. You cannot add 5 meter per second with 10 RPM. So you need to change one of them. So the relationship between linear velocity and rotational speed can be written as U is equal pi dn over 60. So n here is in RPM, rotation per minute, and U here is in meter per second. Or in some textbook, they will give you U is equal R omega is equal to pi dn over 60, which is n here is in RPM. So U is still in meter per second and R is in radian. So radian, there are no units, and omega here is radian per second. No, radian per second, so R. Okay, sorry. R here is in meter because it is radius, and omega here is radian per second. So radian is actually without no unit, so the total unit is still in meter per second. Okay, so here I hope you could do properly, because in certain textbook or certain question they will give you in rotation per second. So here if they give you rotation per second, so no need for you to divide by 60. Okay, please be careful the usage of linear velocity and rotational speed. Because normally in when you talk about rotating object, so they will give you in RPM. Okay, so that's why in your car you have two units to measure your velocity from distance from point 1 to point 2. They will give you in kilometer per hour, but to give you the rotational shaft inside your engine, the torque and so on and so forth, so they will give you in RPM. So that's so it is also carry meanings the speed of your piston. Okay, but actually the rotation, the RPM here is reflecting the torque occur from your engines. Okay, now I hope you could imagine what is the idea of flow around cylinder. So means that you have a cylinder here, then you rotate this cylinder with certain speed, and then a linear flow comes like this. So what we could do here is we immediately could add or could combine the streamline for flow around cylinder with vortex. So this is the common method for flow around rotating cylinder. So here, okay, we derived this equation previously. So this psi cylinder means the combination of doublet plus linear. So and then we add vortex here to reflect the rotation of this cylinder. So and then if you see this equation, so you could see that here this is the psi combination for flow around cylinder. So we discussed this previously. So and then we add with vortex. So please look your notes for vortex. At the beginning I introduce you 4 basic patterns, which is linear, source, sink, and vortex. And then we derive our vortex as negative gamma over 2 pi ln r over A. Please make sure that you have r over A here, because in certain textbook they will give you vortex basic flow vortex basic stream function as negative gamma over 2 pi ln r, because you need to calculate at this stage to make sure that you will have ln r over A. So but I show you the different way. Okay, di sini awak kena berhati-hati. Sila lihat nota saya yang terdahulu berkenaan dengan derivation of vortex. Kerana di dalam sesengah buku teks, dia memberi nilai stream function untuk vortex dalam keadaan yang paling mudah, iaitu gamma over 2 pi dan ln r. Dia tidak ada nilai r over A. Okay, so boleh So saya di peringkat awal saya telah keluarkan, saya telah tunjukkan juga bagaimana nilai A ini wujud. Oleh itu please diharapkan pelajar boleh rujuk semula nota yang terdahulu bagaimana kita mengeluarkan nilai A di dalam vortex. Kenapa saya keluarkan nilai itu awal? Kerana ini pada saya memudahkan pelajar, kerana di sini kita hanya mencampurkan nilai string function flow around cylinder dengan vortex. Oleh itu kita masukkan nilai ini adalah nilai stream function flow around cylinder dengan stream function daripada vortex. Okay, setelah kita campurkan, so after we combine this one, so we have this. Please make sure that you understand these problems. Okay, first, if cylinder is not rotate, jika sekiranya silinder tidak berpusing, so it means that the value of gamma here is equal to 0. So what happens if gamma equal to 0? So if gamma here is equal to 0, then the whole terms here will become to 0. Means that the terms here will back into flow around cylinder. Means the vortex is gone. So what you have is flow around cylinder. If the vortex carries certain value, now you are evaluating flow around rotating cylinder. Okay. So and then sekiranya silinder berputar, membawa maksud nilai vortex mempunyai satu nilai, ini akan menyebabkan bahagian atas silinder mempunyai had laju yang tinggi dan bertekanan rendah. So yang ini saya rasa awak faham, ia adalah reflecting the Bernoulli equation. So when the velocity is high, so the pressure is low. So and then bahagian bawah silinder akan mempunyai had laju yang rendah dan bertekanan tinggi. So perbezaan tekanan ini akan menghasilkan daya angkat lift force. Dia juga dikenali sebagai Magnus effect. Okay. So ini adalah idea yang akan kita lihat selepas sebentar lagi. So untuk memahamkan keadaan ini, okay, bolehlah awak berfikir seperti ini. So katakan, let's say we have one cylinder here and this cylinder rotate at certain velocity. So and then when you have a linear here, so and then please imagine that this linear will flow around cylinder like this one. Okay. So and then for example at this point, okay, for example at this point, so you know that the molecule here will move like in this direction from right to the left, and at the same time the cylinder is rotate from right to the left. So means that it seems that this cylinder actually help this molecule to move faster. So that's why at this situation, at this area, the velocity the velocity is higher and it will create low pressure. So at this point, you know that the molecule here will flow like this one. So mean the molecule flowing from right to the left, but the surface here is actually rotate at reverse direction. So it seems that the surface itself give resistance of the flowing molecule here. because the direction is different. So means that the velocity has low velocity, and then it will create a high pressure. So what happens if you have a high pressure here? So when you have high pressure, multiply with the surface here, they will give you a high force. So that high force, so we have high force here, and at the top here we have a low force. And you know, when you have a very big force here, so versus very small force here, so the big force here will become a dominant force. So awak pun boleh imagine jika tekanan tinggi berada di bawah, so dia akan berjaya menolak objek ke atas kerana daya yang bertindak di bahagian atas adalah rendah. Oleh itu, apa yang akan terjadi? Kita dapati bahawa objek ini boleh terangkat. So inilah yang dikatakan sebagai Magnus effect. So kita akan lihat berkenaan dengan Magnus effect secara realitinya, okay, selepas nota ini. So then we could calculate the velocity components here. So we could get the value of UR here. So how to get the UR? So you need to refer from the Cauchy-Riemann equation. So you derive from Cauchy-Riemann equation. So this is the stream function for rotating cylinder. So you will get the UR here is like this one. And then if you substitute the value of R equal to A, then you will get UR here is equal to 0. So, and then we could calculate the value of U theta. Again, we are using the Cauchy-Riemann equation. So you derive it here. So, and then you will get the U theta here is equal of this term. So and then, okay. Now we calculate the stagnation point. So the problem is, for example, we have a cylinder here and cylinder is not rotate yet. So cylinder belum lagi berputar. So kita dapati bahawa kita telah buktikan stagnation point berada pada 0 dan 180 darjah. Okay, tetapi apabila silinder ini berputar dengan certain kelajuan, adakah stagnation point masih berada pada 0 dan 180 darjah? Oleh itu, kita perlu membuat pengiraan untuk membuktikan kedudukan stagnation point. Okay. When you do calculation about stagnation point, the rule of thumb that you must follow is the velocity is equal to 0. So we use the advantage of stagnation point, which is the velocity is 0. So let's say we start with UR here. So if UR equal to 0, so we prove that the R is constant, which is equal to A. So and then when we have a U theta here equal to 0, so we find that the sine theta here is actually equal to negative gamma over 4 pi UA. So what is the meaning of this term? So it is meaning that the sine theta here is actually influenced by the value of gamma. So kalau awak membuat pengiraan, awak dapati bahawa U theta ini sama dengan 0, menghasilkan nilai sin theta sama dengan negatif gamma per 4 pi UA. So for 4 pi UA here, all of this value cannot be 0. Okay, so because 4 is integer, pi is integer, U is the linear velocity, and A is the radius. Okay, so means that there are no influence from this term, because this term is actually the initial condition. So for pi is a numbers, U is a linear. So if U is equal to 0 means there are no flow of linear. Maksudnya tidak ada hal laju linear, so awak akan hanya ada doublet. Okay, boleh. So and then A adalah radius, menunjukkan jejari di sini. Okay, oleh itu yang kita tulis sebagai kedudukan theta dipengaruhi oleh kekuatan vortex, kerana nilai gamma sahaja yang boleh berubah-ubah. Kerana nilai gamma akan merujuk kepada berapa laju pusingan silinder. So awak boleh lajukan silinder, awak boleh perlahankan silinder. Oleh itu, jika kita melihat dalam rumus ini, kita dapati bahawa nilai gamma di sini mempunyai 4 keadaan. Iaitu kalau kita lihat gamma per 4 pi UA, kita boleh kata gamma mungkin lebih kecil daripada nilai di bawahnya. Gamma mungkin sama dengan nilai di bawahnya. Gamma mungkin lebih besar daripada nilai di bawahnya. Dan juga gamma mungkin sama dengan kosong. Jadi kita lihat keempat-empat keadaan tersebut. First, let's say we assume that gamma is equal to 0. So when gamma is equal to 0, so sin theta is equal to 0. So when sin theta is equal to 0, we could prove that the stagnation point is occur at theta equal to 0 and theta equal to 180 degrees. Okay. So and then, let's say the value of gamma is less than 4 pi UA. So if it is less from 4 pi UA, so we could get value of sin theta is less than -1. So when the value of gamma is less than -1, you already know that the stagnation point is at this region and also at this region. So means that the theta here, as shown in these notes, it is between pi and 2 pi because it will occur at this region. So and then, if gamma is equal, so mean if gamma is equal to 4 pi UA, so we will get sin theta is equal -1. So if sin theta is equal to -1, so means that the theta is equal to 3/2 pi, which is 270 degrees. So it shows that the stagnation point is actually occur at one point here. So and then if the value of gamma is greater than 4 pi UA, so what we have here, if the gamma is greater than 4 pi UA, so the value of sin theta is greater than -1. And then in sin theta, in sinusoidal curve, sinusoidal wave, you must know that it cannot exceed 1. It is never for you to get sin theta 2.1, 3.1 and so on. Okay, so means that it is impossible or it cannot be solved because the mathematics expression here is wrong, is incorrect. But the stagnation point is actually occur. If you do the experiment and so on and so forth, so you will get the stagnation point is actually occur. So where the stagnation point, so we assume that the stagnation point is actually not on the surface of cylinder. So awak kena faham, sekiranya nilai sin theta lebih daripada 1, kita tidak boleh menyelesaikan masalah sin theta. Tetapi nilai ini bukanlah membawa maksud tidak wujud, ia membawa maksud equation kita tidak dapat menyelesaikan permasalahan yang berlaku. Kerana secara realitinya boleh berlaku stagnation point di luar. Okay, tetapi maksudnya apa? Maksudnya stagnation point berlaku bukan di atas permukaan silinder. Kenapa ia berlaku bukan di atas permukaan silinder? Kerana psi combination yang kita gunakan untuk penyelesaian masalah adalah reflect bentuk bulatan ini. Okay, so oleh itu, oleh kerana garisan ini kita kata telah keluar ataupun telah terkeluar daripada bulatan itu, oleh itu kedudukan stagnation point di sini kita tidak boleh kira menggunakan equation yang kita ada. Kerana equation yang kita ada hanyalah represent bentuk bulat yang ini. Okay, yang itu saya harap awak dapat faham, kerana di dalam matematik kadang-kadang kita mendapat jawapan yang berlainan. Okay, awak perlu terjemahkan kepada maksud yang betul. Bukanlah membawa maksud jawapan yang salah tu tetap berlaku. Mungkin kita kata mathematics expression itu tidak bersesuaian dengan real application yang berlaku. Okey, kita teruskan lagi sedikit berkenaan dengan pressure on cylinder surface. Okey, di sini barulah kita boleh mengira pressure, sebab tadi kita cuba mengira pressure, kita dapati semuanya akan force akan menghasilkan nilai kosong. Okay. Tetapi di dalam rotating cylinder, kita perlu ingat bahawa wujud perbezaan pressure. So, yang saya terangkan tadi, velocity is different, so the pressure is different, and then the total force will occur. Okay. Jadi, saya harap awak dapat faham, pressure on cylinder surface can be calculated as shown like this one. So, ini adalah sebenarnya idea yang sama. Kita ada aliran silinder berpusing dengan certain velocity. So kita ambil point nombor 1 di sini, dan ini adalah point nombor 2. Oleh itu point nombor 1 sini kita nyatakan sebagai capital U. Okay, ini maknanya ini adalah point nombor 1. Dan point nombor 2 di sini kita nyatakan had laju adalah sama dengan Q. Kerana apa? Ini adalah resultant velocity. Okay, awak kena ingat yang itu. Awak tidak boleh mengambil nilai UR sahaja atau U theta sahaja. By right, in official term, it is Q because it is the resultant velocity. So, but the resultant velocity is actually consists of U theta only because there are no UR. So, and then what we do is we substitute the value of P2. Okay, I'm sorry, here is P2. Okay, I hope you could change this note. So this is P2. So and then P2 is equal to P1 minus 1 over 2 rho U2 square bracket 1 over Q square over U square. So I hope you could do this at home. You just bring this term to the left hand side, and then you could have the term for P2 here. So and then we substitute the value of Q here. So Q here is equal to U theta. Okay, I hope you could flashback the notes here. So the UR is equal, when we substitute the value of R equal to A, the value of UR is equal to 0. So means that there are no UR. Maknanya UR langsung tidak wujud. Yang hanya adalah U theta. So kemudian kita masukkan nilai resultant velocity as Q theta. So and then it is equal to this term. So from where we get this term, so we could get it from Cauchy-Riemann equation. So ingat semula kita ada psi combination. So and then kita derive menggunakan Cauchy-Riemann equation untuk mendapat UR dan U theta. So we use the value of U theta because UR is equal to 0. So we substitute into this equation. So when we substitute to this equation, we expand the term, so we could get, okay, because kita ada Q kuasa 2 di sini, jadi apa yang saya buat selalunya saya akan kuasa 2 dahulu. So kita ada Q, you could see here, okay, Q is equal this term. So and then if we square the value of Q, so we get this term, and then finally we substitute the value of Q2 and we could get this term. Okay. So and then if we calculate lift force per unit width, okay, so we use this equation. So we have the integral of P2 sine theta A d theta. So the limit is 0 from 2 pi. So and then we substitute the value of P2 here. So we have all of this term. So and then we simplify it. So we know that sine theta d theta from 0 to 2 pi is equal to this one, and it is equal to 0. So if you expand this one, you do the integration, and then you substitute with this assumption, okay, this, and then you will get the FL is equal of this one. Okay, you have, and then if you do the integration, so the integration is actually to the theta. So kamera di sini hanya fokus kepada theta. Oleh itu 1/2 rho U kuasa 2A di sini tidak akan terlibat. So yang terlibat sebenarnya adalah sin theta. Okay. So setelah awak selesaikan kameran terhadap sin theta, awak boleh dapat satu keputusan ataupun satu term seperti ini, dan awak masukkan nilai 0 hingga 2 pi. So setelah awak masukkan 0 hingga 2 pi ke dalam nilai theta tersebut, so awak akan dapati bahawa FL can be represent as this equation, rho U and gamma, which is rho here is the density of fluid. So the rho is the density of fluid, U here is the free stream velocity, means the linear velocity, and the gamma here is actually the strength of vortex. So strength of vortex means how strong the rotation of your cylinder. So ini yang dipanggil satu teorem. Berdasarkan idea ini dikenali sebagai Kutta-Joukowski theorem. Okay, seterusnya kita mengira lift force di sini. Okay, silap. Okay. Sama juga, okay, yang ini mungkin pengulangan, kita masukkan nilai yang sama di sini. So kita melakukan pengiraan, kita kamirkan kepada sin 2 theta dan kita dapat nilai ini, dan akhirnya kalau kita masukkan nilai, so kita boleh dapat nilai FL adalah sama dengan rho U gamma. So ini dikenali sebagai lift force. Kerana apa? Kerana total daya yang bertindak adalah daripada bawah ke atas. Oleh itu dia mampu untuk mengangkat sesuatu objek. Okay, maksudnya rumus yang awak kena ingat, okay, di akhir teori ini ialah FL equal to rho U and gamma. Okay, sampai sini ada apa-apa masalah ke? Okay, nota yang ini saya tak tunjukkan derivation. So kalau yang derivation adalah berdasarkan nota ini. So mana awak boleh tengok nota ini. So kita pergi kepada step ini dan akhirnya kita boleh dapat FL sama dengan rho U gamma. Okey, kemudian saya ingin membuat pembincangan berkenaan dengan lift force yang telah kita dapat di sini. Pertama, sekiranya kita ada silinder di sini. Okey, so ini kita kata dalam keadaan XY di sinilah. Okey, so kalau di dalam XY di sini, kita dapati bahawa pressure di sebelah bawah adalah tinggi. Oleh itu dia menghasilkan force yang lebih tinggi dan dia boleh menolak silinder ini ke atas. Okay. So ia dikenali sebagai lift force. Okay. Sekiranya silinder tersebut awak letakkan menegak seperti ini, okay, maksudnya ia masih lagi XY dan di sini. So apabila ia berpusing pada certain rotation direction, so akan ada pressure yang tinggi dan ada pressure yang rendah. So menyebabkan ia daya yang terhasil adalah berbentuk dalam keadaan horizontal. Okey, dan ia menyebabkan silinder ini bergerak dalam arah horizontal. So di dalam keadaan ini kita kata mungkin kurang jelas sama ada daya yang bertindak adalah drag force ataupun lift force. So di dalam keadaan ini kita selalunya kita akan klasifikasikan bahawa daya yang bertindak di sini sebenarnya adalah drag force. Okay. So cuma yang saya harap, maksudnya yang saya harap awak dapat berfikir ialah awak perlu faham mekanisme bagaimana sesuatu silinder itu bergerak. Awak boleh memahami pada arah manakah aliran ataupun total force itu bertindak dan melakukan pergerakan. Okay, jadi jangan kata kalau silinder yang berpusing ini akan menghasilkan daya dan sebagainya, awak imagine silinder ini bergerak ke atas pula. Okey, kerana kedudukan daya tersebut tidak membantu untuk menggerakkan silinder itu ke atas.